Saxon Algebra 1, Lesson 101. Greetings, students, to week 2 of 6 of our assault on the end of the year. This is a special day because, as you guys know, you each have an older sister who is beginning the transition out of high school math and into college level math. It is a very exciting time for me because it's the big payoff, right? All this hard work that Abby and Jayla and Laura and Vivian Rice are also doing this year. They're all getting ready to make the jump to hyperspace, college level math. They're going to get free college classes. It's not unusual for high school students to go to Running Start and take English, sciences, history, but it's very, very unusual for high school students to be able to attend the college and take college level math. They can take high school math, but you have to pay for that. College level math is free, but you have to test into it. And not many high school students can test into college level math. In fact, it's almost unheard of that high school students in traditional schools like Meadowdale, Woodway, blah, 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 Kamiak, I live right by Kamiak, they just don't have the preparation. They don't have the depth of study that we can get in our classes. And so kids from those programs typically don't test into the college level classes. But if you do Saxon, you will be prepared, and they're going through a special review process now, as you will see. These books will take over your house. But I want you to be aware that Running Start is out there, that in terms of math, you're eligible as soon as you begin your junior year. And as soon as you finish the red book, which is what we'll be doing next year, you're prepared mathematically to take college level classes, and I can help you pass the tests to get into it. So it's an exciting time, and I'm pumped up for those ladies. We, however, still have some lessons to do. It's going to be really fun. I mean, there's no pressure on you guys. We're talking about factorable denominators. All right, let me show you the problem, and then I'll explain what in the world we're talking about. You know what I always hated? I hated when the math teacher, I had the conventional chalkboards and desks situation. I went to traditional school. I hated when they would stand there and give you some big theoretical preamble. I'm like, I'm so bored and I get this. But I'm not enjoying this and I don't want to listen to this. Just show me what to do. So that's what I like to do. I like to skip the preambles, show you what to do, and then sometimes I can go back and be like, okay, now I'll give you the boring preamble, but you've already learned the important part. Okay, add. And then we have fractions and technically a minus sign. So why doesn't it say subtract? I don't know. We're kind of past the whole subtraction thing, aren't we? We don't even care about it anymore. Adding negative numbers, it's fine. Okay, what's the rule about adding or subtracting fractions? The denominators have to match. It's such a pain, isn't it? Fractions are so annoying in that respect, but the booties have to match. Now, the problem is, look at these two denominators. They do not look like anything similar, do they? They're on complete crack, if I may be so bold to say so. So what are we going to do? How are we going to make these things match? Well, here's a fun little hint. Let's try factoring this first, right? Looks like something we could factor. Let's try breaking that down and seeing if that helps us at all. So we know, okay, this is in good order. So we're going to go like this, right? And we're going to look for two numbers that multiply to minus 12 and add to, this would be minus 1, right? We can squeeze that in if that helps us. Aha, I've got an idea. How about x minus 4, x plus 3, right? This works. Minus 4 times 3 is minus 12. Oh, my hands are dirty because I gardened all weekend. Sorry. You have a farmer for a teacher. Minus 4 times positive 3 is negative 12. Check. Minus 4 plus 3, minus 1. Check. So what I'm going to do is I'm just going to lightly squiggle this out. Dear students, please don't erase ever in your lives. Sometimes when I'm listening to you do your review problems, even if I don't usually look at you, some of you, Caleb, is it you that does it? Some people turn their cameras off, or at least they don't look away. I don't watch you, but I listen, and I hear oftentimes erasing. It makes me crazy. Don't erase. Just draw a little line through it. Okay, now look. Oh, that's so much better, isn't it? Now, all we have to do, this part's the same. So we can kind of think of this as our least common multiple, but we can see if we just multiply this side by x plus 3, top and bottom, they have to be the same. Now they match, right? Because this is, I can put parentheses around that if that helps me. Those two, these two, yay! So the denominators match, and I get for my answer 6x minus p times the quantity. See how I just write those as being multiplied together? All of this is the same. And then it's all over okay? Now, we can't cancel these. We can't cancel those. There's a complicated rule about that we haven't gotten to yet. But basically, anytime we're adding or subtracting anything, we can't cancel. Okay, we can only cancel when we're multiplying. So get that idea out of your head. What we can do, though, if we want, is we can distribute 6x minus px minus 3p, right? And then over okay? I would call either of these perfectly acceptable answers. Factoring or not factoring is never, there's never a clear black and white right or wrong on that. In some cases, it's nice to factor. In other cases, it isn't. Same for the bottom. If I wanted, I could put it back in this x squared minus x minus 12. I don't like that, though. I like to leave it factored in the denominator. Either one of these, John has this in his numerator, but he has that in his denominator. Oh, he's a wily devil. But I prefer one of those two. Let's try another one. Ready? We're told to add again. I'm not going to write that. Okay. Now sometimes students see something like this and they go, okay, well they both have x squared. And this has a 5x and this has a minus x. So maybe we can like multiply this by like x minus 6 or something. No, that's not the way you do it. Don't even try to fix it like this. What we want to do is factor the denominators and see what we get. And I promise you, John makes them cute. So let's do just like we did last time. Let's factor this as a trinomial, the way we're used to doing it. Two numbers that multiply to minus 6 and add to minus 5. This is a tricky one. Think about it for a minute and see what you get. Okay, a lot of times the students go, oh, 6, that's 2 and 3, because look, minus 2 and minus 3, that adds to minus 5, and it multiplies to 6. No, because negative 2 times negative 3 is positive 6. So this does not work. The one that works is negative 6 and positive 1. That's tricky because of the way the math works on these. It's so similar with the 5. So be careful with your signs. So x minus 6, x plus 1. Okay, good. Lightly squiggle. No erasing. All right, now this isn't a trinomial, so we can't factor it this way. But we could at least pull an x out, right? So let's do that. X, when we take an x from x squared, we're left with another x. When we take an x from 6x, we get that. Make sense? I'm squiggling. Okay, now last time our LCM was the big one and we just fixed the smaller one. This time we're going to have to combine them. Our least common multiple is going to be, it's going to have the x minus 6 and it's going to have the x plus 1, but it also has to have that plain x. I'll squeeze it in at the front end so that it looks neater to me. All right, so that's our least common multiple. We have to make each one match by multiplying top and bottom. This first one, all I need is the x. So I'm going to put the x over x. And then this one I have to multiply. Let's see, I have the x and the x minus 6, so I need the x plus 1. And that finger's really dirty. Never mind. Okay, beautiful. Oh, it's so sad, you guys. My next door neighbors, the people who lived there originally, there was a great big maple tree in the front yard. Oh, I said was. I just tipped the story. It's a giant maple tree. It was so gorgeous and pretty. I watched it ever since it was a little baby. I've lived in this house since the house was built. It's been 35 years. What? But this tree has always been there outside my front window. It's so pretty and gorgeous. And the new neighbors who moved in, I don't know, a year and a half ago, cut it down yesterday. Tragedy. Tragedy has unfolded. I love trees. Okay, so now our denominators match and we just have to clean this up. So I'm going to say it's 7x minus 5 times the quantity x plus 1 over x times x minus 6 times x plus 1 quantities. Okay, so I just scooched all that together. Now, what I notice is I could leave it like this, but if I multiply this and get 5x, then I can do 7x minus 5x, and I kind of like the idea of that. So I'm going to distribute, and over here I'm going to write my answer, 7x minus 5x minus 5. 7x minus 5x is 2x. So my final answer is going to be 2x minus 5 over this beast again. I was trying to figure out a way not to have to write it again, but I couldn't think of one. That's my answer. Let's check and see if John agrees with me. John knows what he's talking about. He agrees. Yay. I hope you can see this. I feel like my camera angles have been off lately. Okay, you should be okay. My light, I'm not happy with my other light. I have so many problems, you guys. You don't even know. Okay, one more problem. Yes. Have you noticed John's really been going crazy lately with giving you guys lots of examples? I mean, it's nice, but makes the lessons longer, doesn't it? Not that you don't enjoy every minute. Of course I'm not suggesting that. I know you do. Ready? Again with the subtraction. Okay. I'll let you copy. And same thing. We don't even try to make these match in their current form. We're just going to factor first, see what we've got, and then we'll figure out an LCM and fix them. Factor first. Let's write that. Factor first. And I'm not going to write this down because I hate to write down really long rules. But what I mean by factor first is just the denominators. Okay, we don't have to worry about the tops. All right, here we go. And notice this one has the same pattern. This one's a proper trinomial. This one's just a weirdo that we'll do the best we can with. Okay, minus 6 and a plus 1. Let's squeeze it in. Okay, I'll write it down. You write it down. We'll see if we're the same. Yay, we're the same, aren't we? I know you got it right. Okay, squiggle that out. We don't want that anymore. And then this one, we just pull the x. A lot of times that's what John does for this one. X plus 3. Right? Does that make sense? It's so easy, it's hard sometimes. We're just pulling the x out of both. And we're kind of de-distributing, right? It's the opposite of distributing. Because if we distribute it back, then we'd get x squared plus 3x. Yay, it works. Okay, now let's write an LCM. It's going to be another one of these massive ones. It's this, x plus 3, x minus 2. That's the x plus 3. We need that. Okay, so there's our little LCM. Cute little double. And now we have to give them the missing pieces. This fraction has the big 2 chunks. It just needs the x. So I'll do x. I like to put it in parentheses sometimes so I don't lose it. Right up here, it would be easy to lose it. And I'm going to put this in parentheses so that I can sort of see what I'm doing here. I'm going to have to do that. And then over here, let's see, I've got the first 2. I need the x minus 2. And then this will be x minus 2. And then I'll distribute that, right? And it's a minus, so I'm going to be distributing the minus 4. I'll think about that as well. All right, so our denominators are cute. This is a hot mess, isn't it? Okay, let's figure this part out. So we're going to have 4x squared, right? 4x times x plus 2x minus 4x plus, see the two minuses make a plus, 4 times 2 is 8. Woo! Hot tamales, right? But we're fine. We've got this. We can combine like terms. Gracie's sighing in her sleep. 4x squared minus 2x plus 8. Technically, we could factor a 2 out of all 3 of those terms, but that's not going to help us. This is fine. As an ending place, we've combined all the like terms, and now we'll put it over this hot dog. And that is our final answer. Let me check and make sure John agrees. 4x squared minus 2x plus 8 over x times quantity x plus 3 times quantity x minus 2. Yay! Guess what? That's the end of the lesson. Now all you have to do is like 17 problems and then go live the rest of your life. Fun, right? Okay, thank you. Goodbye.